All right, everybody, here we go. Moving on into section 4, the last section in Mod 12. And I want you to erase or just scribble out, rather, where it says experimental probability with compound events. I forgot to change the title. So the first thing I need you to do at the top of this page is change it to making predictions. And this is with experimental probability. So, our essential question is, how do I make predictions with or using experimental probability? Okay. Ta-da, here we go. Probability. Okay, now I'm going to ask you, please make sure you have your calculator ready. And I'm going to make sure that I have that up and ready to go. I think I have my calculator right here. Okay. And we're going to flip-flop back and forth, but we're going to use an awful lot of percent today with our calculations. Okay. So take a look at this first one. You've got a dartboard, and Danae has found that her experimental probability of making a bullseye when she throws darts at the dartboard is 20%, or 2 out of 10. Okay. If she is going to attempt 75 throws, so out of those 75 throws, about how many bullseyes could she predict she would make? So honestly, it's as simple as this. Write down 20% times 75, and then if you need to, grab your calculator and go ahead and type in on this one 20% times 75. Now, as a little detour here, there's something else I want to just go back and say. If you got really good at calculating 10%, because 10% is really easy to calculate, 10% of a number just means move that decimal point in one spot to the left. 10% of 75 is 7.5. So 20% would be double this, which is exactly 15. Some of them you can do really quickly in your head. Some of them, bull's eyes. I'm trying to think how to make that plural. Some of them definitely use a calculator, but you should always, before you even touch the calculator to do the computation, always try to have a reasonable idea in your head, so that when you use your calculator and you accidentally press something, you're not like, whoa, 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 that's way, way out of whack. All right, look at the second one. Honestly, this is how fast it goes. Car rental company sells accident insurance to 24% of its customers. So out of the 550, about how many customers are predicted to purchase this insurance? So you're going to take 24% times 550. Okay. Oh, by the way, I'm going to clear that away. So 24% times 550. Boom. And we get 132. Okie dokie. So we get 132 customers is what we would anticipate would be buying that supplemental accident insurance. Okay. And then we could use that information to perhaps try and predict some sales or predict some other things that are happening. Okay. Cool. All right. Let's look at this very last one here. It says a doctor's office records data and concludes on average 11% of patients actually need to call and reschedule their appointments every single week. Wowza. That's a little higher than I anticipated. That's a lot of extra work to try and plan for, huh? All right. So the office manager predicts now that there's going to be 23 appointments that need to be rescheduled. Okay. So the prediction is that she thinks we're going to have 23 appointments that have to be rescheduled. The data that we have says it's going to be about 11%. So when we look at the actual data, take 11% times 240 appointments. And what we want to do, in a qualitative way means we're going to look at these two predictions and see if it makes good sense. All right, so let's bump this up a little bit. 11% times 240, grab your calculator. In my head, I'm thinking 10% of 240 is 24. So 11% is going to be a little bigger than that. And sure enough, it is. You get 26.4. Now, that's the math number, but since I'm talking about the number of appointments, you'd round this to be about 26, okay? So my data tells me 26 appointments. The prediction that the office manager made was 23. Explain whether the prediction is reasonable. Do you think this is reasonable? I'd say yes. I'd say the prediction is reasonable. Of course, there's going to be some variation. It's not going to be exactly, because people aren't always predictable. So we just do the best we can. The prediction is reasonable. I'm just going to add on there. It's a little lower than what our data suggests. So we might want to prepare for that if you need to staff up for that or have some more flexibility. Okay. All right. Flip and let's go to the last ones here. All right. On the back page. In emails to monthly readers of a newsletter, 3%, let's get that number, 3% of the emails come back undelivered. So that means they bounce back, the address is not valid, something's going on. The editor predicts that if he sends out, 12,372 emails, he will receive 437 notices for undelivered mail. Do you agree? Well, let's use the data that we've got, the 3% of all the emails, 12,372. Let's get that number, and then from there we should be able to 12,372. I'm trying to remember that number, okay? All right, so we're going to take 3% times 12,372 emails. Yikes. 371 and 1600ths. 371.16, which, of course, because we're talking about emails, we aren't going to have a part of an email. So that would round to about 371 emails. Okay. Now, the editor is predicting 437. Do you agree with that prediction? I would say no. The prediction, or the editor's prediction seems high. According to our data, it should be less than that, because he's coming up with 437 compared to 371. That seems a bit high. All right, now the last ones here are what they call quantitative predictions. So let's take a look at this movie. An online poll for a movie site shows that its polling results are posted for this new movie. And if a newspaper surveys 150 people, and they're leaving this particular movie, how many people can it predict will like the movie based on this poll? Well, I'm looking at this and it says 72% yes, like the movie. So the first thing I want you to do is let's figure out what 72% of 150 amounts to. Now, 72% is more than half. It's almost 3/4 of these people. And so I know halfway would be about 75, and so another half again as much, another 30. So yeah, about 3/4, about 100 or so. When you do this calculation, 72% times 150, I think we get something like 108. Does that sound right? I better check, just because I haven't had enough coffee yet. 72% times 150. Yep, 108. So when they are asking us if the movie sites claim claims to be 104, is that claim accurate? If the newspaper had 104 people say they liked the movie, could you say it's? I would say yes. Yes, because 104 and 108 are close to each other. And so for that reason, I would say that their prediction is pretty accurate. Last one. On average, 24% of customers who buy shoes in a particular store actually buy 2 or more pairs. Of course, who doesn't want more shoes? 24%. I'm going to write that one down. On one weekend, 350 customers purchase shoes. How many can be predicted to buy 2 or more pair? Take 24% times 350. 24% times 350. 24% times 350. 84. Alrighty, here we go. 84 customers. So that answers the first question. Okay? That's what we're predicting. If it actually was 107 customers that bought more than 2 pairs, did more customers than normal buy 2 or more pairs of shoes? Yes, way more. Yes, 107 is larger than 84, which was our expectation. Ta-da! That's all you got to do. So either you're just directly finding the predicted value, or you calculate that predicted value and compare it to a different prediction and see if your data says that they are pretty close. All right? Go ahead and look at Schoology for your assignment. It's in your textbook. And as always, good luck, and may the force be with you.